Hi everyone, let's solve this GATE 1991 question. If F1, F2, F3 are propositional formula such that this and this are both tautology, then which of the following is it true? So this is a question. Now before you solve this question, you should have clarity. Okay, what is a propositional formula and what is a propositional variable? So what is the difference between propositional variable and propositional formula? So propositional variable, for example, if I say that P, comma, Q, comma, R, they are propositional variable. So propositional variable actually represents atomic proposition. So this P, Q, R, they are atomic proposition. And atomic proposition does not depend on anyone else. So the truth value of R does not depend on anyone else. The truth value of P does not depend on truth value of anyone else. The truth value of Q does not depend on anyone else. So propositional variables, they represent atomic propositions. So this PQR, if I say that they are propositional variable, if I say that these are propositional variable, then they represent atomic proposition. R represents atomic proposition, Q represents atomic proposition, P represents atomic proposition. Okay, and atomic proposition by itself is true or false. Atomic proposition does not depend on anyone else. Okay, so these are the propositional variables. Now what is a propositional formula? Propositional formula is basically, for example, I can say P implies Q. This is a propositional formula. This is not a propositional variable. Okay, P is a propositional variable, Q is a propositional variable, and this complete expression, this is called propositional expression. Similarly, I can say P and P bar. This is a propositional formula. Similarly, okay, this every propositional variable is also propositional formula. So this P is also propositional formula, Q is also propositional formula, R is also propositional formula. So every propositional variable, that is a propositional formula. And also what you can do, you can do the negation, implication, by implication, conjunction, disjunction. Okay, all the things you can do on propositional formula. For example, I can say that P implies Q implies P. This is also a propositional formula. Okay, so it is like this. For example, if I write an equation x plus 2y is equal to xy, this type of equation if I write, okay, in mathematics, in normal mathematics, if I say that this is the equation, now you can notice this is a variable. Okay, remember, this is a variable, this is also a variable. I can say in normal mathematics, in general mathematics, in algebra, I can say if you have this equation, then I can say this x comma y, they are variable, but this is not a variable. Don't say that xy is a variable. Xy is not a variable. X is a variable, y is a variable. This xy is called expression. This is called expression. So similarly, I can say that p, q, r, these are propositional variables. But this p implies q, this is not a propositional variable. This is not a propositional variable. This is a propositional expression, or I can say this is a propositional formula. This is a propositional formula. Every propositional variable is also propositional formula. Okay, so this is the difference between propositional variable and propositional formula. For example, you can notice that this is a propositional formula, p implies q. Okay, so this is a propositional formula. Okay, and if you notice, okay, the truth value of this is a propositional formula, and the truth value of this will depend on the truth value of p comma q, because these are propositional variables. Okay, but remember, the truth value of p comma q does not depend on anyone else. They are either true or false. They by themselves are true or false. So I am saying that the truth value of this will depend on truth value of p comma q. But p comma q, they are propositional variables, so they are atomic proposition. Okay, this p is an atomic proposition, q is an atomic proposition. Atomic proposition does not depend on anyone else, so the truth value of these does not depend on anyone else. They by themselves are true or false. So I can say that, okay, they can be, both can be false, or maybe this is true, this is false, or maybe, okay, so these are the possible scenarios. Okay, now finally I can say that this will be the truth table. So this will be the truth table, you can notice. So this is the idea is this, that this is propositional formula. Okay, similarly you can notice, if I tell you, if I tell you that p is a propositional variable, if I tell you that p, if I tell you that this is a propositional variable. Okay, now because you know this is a propositional variable, so it represents a atomic proposition. So p is atomic proposition. So because it is atomic proposition, so it does not depend on anyone else. So by itself it is true or false. So there are two possibilities. By itself it is either true or false. Okay, so this is the point. If I say that p is propositional variable, then by itself p is true or false. So this p can be true or this p can be false. But that if I say that let's assume alpha is a propositional formula. Now I don't know what is this alpha. Remember, if I say that alpha is propositional formula, now I don't know what is this alpha. Remember, I cannot say this that alpha is true or false. I cannot say this. Why? I cannot say this. Why? Because just think about it. This alpha is a propositional formula. I don't know what is this. Maybe I don't know. I don't know. Maybe this is this. Maybe this is this. Maybe this alpha is this. Okay. So you can notice this p is a propositional variable and this alpha is a propositional formula. Now you can very easily see that the truth value of alpha will depend on the truth value of p. This p is atomic proposition. This p is atomic proposition. This is atomic proposition. So either it is true or it is false. Because p is atomic proposition, so by itself it is either true or false. Okay, but remember alpha is a propositional formula. Okay, so this alpha is p and p bar. So now you can notice this p is an atomic proposition, so it is either true or false. By itself it is either true or false. It does not depend on anyone else. P does not depend on anyone else, but this alpha will depend on the truth value of p. So you can very easily say that this is also false, this is also false. So this is the difference between propositional variable and propositional formula. Propositional variable is either true or false by itself. But propositional formula, for example, this alpha, I cannot say that this is true or false. I cannot say because it will depend on the truth value of this propositional variable. So for example, this alpha, if I say alpha is propositional formula, I don't know what it is. Maybe alpha is this, I don't know. Maybe alpha is this. If alpha is this, then you can notice alpha is always false. Okay, so this is the difference. One more point I want to say that, for example, if I ask you, let's assume p is a propositional variable, then what can you say about it? Is it tautology, contingency, or contradiction? So read this question. Let p be a propositional variable. Okay, then p is necessarily tautology, contradiction, contingency. So what should be the answer? Remember, p is a propositional variable. I told you that propositional variable, they represent atomic propositions. This is I told you. Okay, so propositional variables, they represent atomic propositions. They represent atomic propositions. So this p, this represents atomic proposition. Okay, so propositional variables, they represent atomic proposition, or I can say atomic propositions are represented using propositional variables. Now I am saying that let p be a propositional variable. So because this p is a propositional variable, so this p is an atomic proposition. This is an atomic proposition, and atomic proposition does not depend on anyone else. Atomic proposition by itself is true or false. Okay, it will not depend on anyone else. The truth value of atomic proposition does not depend on truth value of anything else. So you can notice, because this is atomic proposition, so by itself it is either true or it is false by itself. So I can say for p, these two possibilities we definitely have, either true or false. So if p is a propositional variable, then it is necessarily a contingency. It is definitely a contingency. Okay, if p is a propositional variable, then it is necessarily it is a contingency, because propositional variable will represent atomic proposition, and atomic proposition is by itself true or false. Okay, so I can say that this is definitely a contingency. Now read this question. Now this is another question. Let p be a propositional formula. Now I am saying that p is a propositional formula. Now what can you say? So instead of p, let me use alpha, so that it becomes less confusing. Let's assume that alpha is a propositional formula. Now what can you say about necessarily? What can you say about alpha? Necessarily, can you say something about alpha? What can we say? Let alpha is a propositional formula. Now what is alpha? What should be the answer? Think about it and tell me what should be the answer. The answer is neither this nor this nor this. We cannot say anything necessarily. We cannot say anything necessarily, because alpha is propositional formula. We don't know what is alpha. We don't know what is alpha. Just think about it. If alpha is this, if alpha is this, where p is a propositional variable, if alpha is this, because alpha is a propositional formula, remember. So we don't know what is alpha. If alpha is this p or p bar, then you can notice that alpha is basically tautology. In this situation you can notice alpha is tautology, but we don't know what is alpha. So if alpha is this p and p bar, I don't know what is alpha, but alpha is a propositional formula. Now, if alpha is this, then you can definitely see that alpha is a contradiction. In this situation, alpha is contradiction. And if alpha is P implies Q, okay, where P comma Q are propositional variable, P and Q, they are propositional variable. Okay, P and Q, they are propositional variable. Then in that case, alpha is what? Now in this case, alpha is, in this case you can notice alpha is contingency. Okay, so in this situation alpha will be contingency, correct? So what you can say, so in this situation answer will be contingency. Okay, so what I'm saying, the question is very simple. If alpha is a propositional formula, okay, we don't know what is this formula. This can be this, we don't know. Okay, so alpha can be tautology, or it can be contradiction, or it can be contingency. So alpha is necessarily, we cannot say that it is necessarily tautology. We cannot say that it is necessarily contradiction. We cannot say that it is necessarily contingency. But remember, when p is a propositional variable, then it will be definitely contingency. Okay, now let's come back to this question, this gate exam question that we want to solve. Okay, so here the question is f1 f2 f3, these are propositional formula. Okay, so remember, we don't know what is these are propositional formula. We don't know what is f1. This f1 can be, I don't know what is f1. Maybe f1 is this, maybe f1 is this. I don't know what is f2. I don't know what is f2. Maybe f2 is this. Okay, I don't know what is f2. Maybe f2 is this. Okay, so basically we don't know what is f1, we don't know what is f2, but they are propositional formula. Okay, so because they are propositional formula, so they use some propositional variable. For example, if you have any propositional formula, if you have any like this is a propositional formula, this is a propositional formula, so it uses propositional variables. These are the propositional variables it uses. For example, this propositional formula is using three propositional variables. Okay, so the question is saying that p f1 f2 f3, these are propositional formula. Okay, we don't know what propositional variable they are using. This f1 f2 f3, which propositional variable they are using, we don't know. But anyway, I just want to tell you that they are formula, they are not propositional variable, they are actually formula. Okay, so f1 f2 f3, they are actually formula. Now the question is saying that f1 and f2 implies f3, and f1 and f2 implies negation f3, both are tautology. Then what can you say? Then which of the following is true? Okay, so the question is saying that both are true, means here remember, f1 f2 f3, these are propositional formula. These are not propositional variable, these are propositional formula. These are propositional formula. Okay, so we don't know what variables they use, but they are propositional formula. And the statement is saying that f1 f1 and f2, okay, so f1 and f2 implies f3. This is also tautology, means this is also always true. Okay, and similarly, the question is saying that f1, f2 implies negation f3. This is also tautology. This is also always true. Then what can you say about f1, f2? Okay, this is the question. Then what can we say? Then what can we say about? Then what can we say about f1, f2, f3? f1 f2 f3, this is the question, this is the question. So let's see. Remember, these are propositional formula, so they have some propositional variable. We don't know what is propositional variable, but definitely they have propositional variable. So this f1 is a propositional formula, this f2 is a propositional formula. These are propositional formulas. Okay, these are propositional formulas. Now if they are propositional formulas, then they have some propositional variables. We don't know what are these variables, but the point is there are some propositional variables. Okay, there are some propositional variables, and this is the truth table. These are the propositional variables on which f1 f2 f3 are defined. So these are propositional formulas on these propositional variables. Okay, anyway, now the question is saying that f1 f2 implies f3. This is a tautology. The question is saying that this is a tautology. So for any combination, this is definitely true. Whatever you do, this is definitely true. Similarly, the question is saying that f1 f2 implies negation f3. This is also tautology. This is also tautology. This is also tautology. Okay, so this information is given in the question. Now what can you say about f1 f2 f3? Remember f1 f remember, so whatever combination you take basically, okay, whatever combination you take, whatever, okay, so this is tautology, this is given in the question. Now what can you say about f1 f2 f3? So let me tell you, just think about it. Okay, let me put f3, because see, for this combination either f3 will be false or true. Let me put true first. Okay, so let me do this. Let me put true. Let's just see. Let me just see what will happen if this f3 is true. What will happen? So for this first combination, for this, okay, for this combination of these propositional, these are the propositional variables. For this combination of propositional variables, let us assume that f3 is true. Let us assume. Now, what should be f1, f2? What should be f1? What should be f2? What should be f1? Notice that because f3 is true, okay, so can I put true, true? Just think about it and tell me, can I put true, true? Can I put true, true? If I put true, true, can I do this? Just think about it and tell me. Pause the video, think about it. Is it possible? It is not possible. It is not possible. Why it is not possible? Because if you do this, if this happens, then you can notice this will be false. Then this will be false. Because remember f1 f2, that is true. True implies negation of true, because this is negation of f3. So you can notice f1 f2 implies negation of f3. So true and true, that is true. Negation of true is false. So true implies false, that is false. So this will be false. So this is not possible. So I can say that this combination is not possible. Definitely this combination is not possible. Okay, so this combination is not possible. So if this is true, so if f3 is true, then definitely they cannot be true. f1 f2, they can never be true. If f3 is true, if this is true, then you can never do this. You can never do this. So at least one of them must be false. At least one of them must be false. F1 or F2. At least one of them must be false. Correct? Now you can notice, now everything is correct. Now in this situation, everything is correct. So, okay, now you can notice, because F1 and F2, that will be false. So this is also available. Okay, you can do this also. You can do this also. All these are correct. So this is not possible. Like if F3 is true, then F1, F2 can never be true. Okay, they both can never be true. Okay, so these are possible, because here f1 f2 will be false. False implies anything is true, because this is what we know. Okay, so this you already know, that false implies anything. False implies anything. This is basically true. False implies anything is true. So I can say that if f3 is true, then these are the possibilities. These are the possibilities. Now if f3 is false, then what will happen? If f3 is false, again they cannot be true. Is it possible that they can be true? They cannot be true. Why? Because if this happens, then this will be false, then this will not be true. So again, this is also not possible. So if f3 is false, again either this should happen, or this should happen, or this should happen, or I can say this should happen. So okay, so these are possible. These are definitely, these are possible. Okay, so these are possible, or I can say these are possible. So what is not possible? This is the point. f1 f2 f3, what is not possible? It is not possible that it is for any combination. We don't know what are the propositional variables, we don't know. But whatever combination you take, it is never possible that this is true, this is true. This is never possible. This is never possible, this thing. Okay, so this is never possible. Why this is never possible? Because remember, f1 f2 implies f3. Okay, this is f1 okay, and f1 f2 implies negation f3. And remember, these are already, it is given that these are tautology. Already it is given that these are tautology. So f1 f2, it is never possible that, okay, both are true. It is never possible. In any case, it is never possible that both are true. It is never possible. Why? because if both are true, then what can you put here? What can you put here? See, if you put false here, then this will be false. Okay, so if you put false here, then this will be false, and if you put true here, then this will be false. So the final point is you cannot put F1, F2 true in any case. F1, F2 can never be true simultaneously. Okay, so at least one of them must be false. If at least one of them is false, then there is no problem, because if at least one of them is false, then this will be false, this will be false. F1, okay, so if at least one of them is false, F1 or F2, at least one of them is false, then what will happen? For any situation, what will happen? This will be false, this will be false, and false implies anything is true. This will be false, this will be false, false implies anything is true. This is what we want. Okay, so the final point is this, that f1 f2 they can be like this, I don't know, they can be like this f1 f2, but this cannot be possible. Okay, this is never possible, this is never possible, this is not possible, this is not possible. Okay, but remember, this is possible, this is also possible, this is also possible, these are possibles. Okay, so these are definitely, these are possible for any, for any case, or okay, okay, for any row of truth table, for any case, or I can say for any row of truth table, any row of truth table, any row of truth table, this is either, this is possible, this is possible, this is possible, but this is not possible. Okay, so finally I can say f1 f2 that can never be, remember, it is not possible, right? It is not possible, true, it is not possible. So what can you say about f1 and f2? What can you say about f1 and f2? It is not possible, at least one of them is always false. Whatever case you take, whatever case you take, at least one of them is always false, at least one of them, at least one of them is always false. So I can say that f1 f2 will be definitely false, 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 false. So I can say that f1 f2 is basically, okay, this f1 f2, this is basically not satisfiable, or I can say this is contradiction, this is a contradiction, or I can say that this is not satisfiable, this is not satisfiable. Okay, so this is the answer. So the answer will be, this is not satisfiable. The conjunction f1 and f2 is not satisfiable. This is the answer. What about option 1? What about option 1? Okay, both f1 and f2 are tautologies. This is not correct. Both f1 and f2 are tautologies. This is definitely not correct, because if f1 and f2 both are tautology, then there is a problem. Okay, so this option is saying that both f1 and f2 are tautology. There is a problem if f1 and f2 are tautology, then f1 and f2 will be tautology. So this is definitely not possible. Neither is tautology. Can you say that neither is tautology? Can you say neither is tautology? No, one of them can be tautology, right? So for example, okay, one of them can be tautology. For example, f1, f2, they can be like this. They can be like this. This is false, 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 and this is true, 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 true. Because remember, the only restriction we have is that for any row, whatever row you take, for any row, this is not possible. Means f1, f2, at least one of them must be false for any row. So whatever row you take, whatever row you take, whatever row you take, at least one of them must be false. Okay, so this is also possible. This is also possible. Similarly, this is also possible. Like, okay, I can say that this is f, this is true, this is okay, this is false, this is false, this is true, this is false, this is false, this is also possible. Okay, because remember, for any row, at least one of them must be false, at least one of them will should be definitely false. Okay, so you cannot say that both are tautology, you cannot say. Okay, you cannot say both are tautology, you cannot say both are contradiction. Here you can notice, here you can notice both are contingency. Here f1 is contingency, f2 is contingency, here f2 is a tautology, here f3 is a contradiction. So we cannot say that both are contingency, we cannot say both are contradiction. Okay, also we cannot say that both are tautology, both cannot be tautology. So the final point is that the from the question I can say, okay, we can say that whatever you do for any row of truth table, for any row of truth table, at least one of them is false, at least one of them is false. Okay, so finally I can say f1 and f2 that is not satisfiable. Okay, so for this question answer will be option B. Okay, and for this question actually many nice variations can be created. Let me tell you what is the problem. In this question f1 f2 f3 they are propositional formula, they are not propositional variable. Many students they solve this question wrongly. They solve this question by incorrect method they solve. Why? Because they consider that f1 f2 f3 they are propositional variable. Okay, but remember f1 f2 f3 they are not a propositional variable, they are propositional formula. We don't know what are they. These are propositional formula which use propositional variable. So for example f2 can be this, I don't know f2 can be this. If f2 is this, then it is using two propositional variable p comma q. Okay, if f1 is this, then it is using three propositional variable pqr. So we don't know what is p, what is f1, what is f2, what is f3, but we know one thing that they are propositional formula. Okay, and then we can apply the concepts, and then finally I can say that whatever you do for any row, for any row in the truth table, both f1 and f2 cannot be true. For any row in the truth table at least one of them must be false. So finally I can say that the conjunction must be not satisfiable. Okay, nothing else. So all the other options you can check, they are not correct, so the only option B is correct. Okay, for this question many variations can be created. Okay, so if you want to solve those variations, then you can find the link in the description. Okay, so many new variations, many I can say complicated variations I have created, and those variations you can try. Okay, so you can find the video in the description. Okay, thank you.